Define an additive manufacturing method. In this video, we'll define manufacturing methods. In Fusion 360, we want to get started with the supply dataset, additive bracket.f3d. This additive bracket should open up in the generative design workspace, but if it doesn't, make sure that you do navigate to generative design. This design already has the preserve and obstacle geometry set. It also has the objectives defined as well as 3 different load cases. We're looking at designing a shelf bracket. We've got 2 preserved geometries, and the main obstacles are simply the bottom of the shelf and the wall it mounts to. We're looking at a load case where we have 20 pounds applied to the top bracket, and then we have various angles at which that load is applied, representing different positions on the shelf. We could go a bit further with this example and use things like point masses on the shelf, but for this example, we're really focusing on setting up an additive manufacturing method. So let's get started by going to Design Criteria and selecting Manufacturing. By default, unrestricted, additive, and milling are turned on. For this example, we're going to focus our attention on additive, but I always like to leave unrestricted turned on just to get a good idea of what those under-constrained outcomes will look like. For our example, we need to determine the direction or orientation of the build. If we don't know that by default, we can always include all the directions or pick multiples. In reality, we have 2 flat faces that are 90 degrees apart. So some orientation of this part might be better than others depending on the machine that we're printing on. We also need to talk about the overhang angle. The overhang angle by default is 45 degrees, but again, this value is going to come from a specific machine that you're using. It's going to be dependent on the type of 3D printer, as well as the support material used and the material in most cases. For our example, we're going to assume an overhang angle that's a bit larger than that default 45, and we're going to set it at 65 degrees. We also need to determine a minimum thickness value. This is going to be important based on the resolution of the printer that you're using, but also the size of the part. For us, the size of our part is going to work well with a 3mm minimum thickness, so I'm going to select OK. Notice that I didn't use cost estimation, and unlike our previous example, this part is actually quite a bit smaller, and it fits well within a 3D printer's build volume. So you can see that the pre-check is already showing up a green check mark, which means that it has all the required information. But from here, let's navigate back to a home view, make sure that we save the design before moving on.